In this video, we are covering 3 higher maths questions. One on kinematics, another one on sequences, and a third one on binomial expansion. A particle moves on a straight line. Its displacement s in meters at time t in seconds is s equals t plus sine of 2t, where t is positive. The first 2 times when the particle is at rest are t1 and t2, where t1 is smaller than t2. We need to find these 2 times and the displacement of the particle at the second time. I always like to start solving any problems having a picture of what is going on. I'm going to draw the graph of y equals x plus sine of 2x to represent the distance versus time. I can see that the particle is temporarily at rest at these 2 points, t1 and t2. To find these values, we differentiate the displacement and make it 0. The velocity is 0 when the particle is at rest. We want to find the values of t that make this equation 0, so we need solving the trigonometric equation. This has 2 solutions, 2 pi over 3 and 4 pi over 3. Dividing by 2, we obtain the time t1 pi over 3 and t2 2 pi over 3. The times t1 and t2 gives you 5 marks. Now, we need to find the displacement of the particle when t equals t2. That is 2 pi over 3 seconds. We set our calculators in radians, very important, and we plug numbers. It returns 1.228 meters. That is 2 more marks for you. This second one is a 4 marks question. The first, the fourth, and the 8th terms of an arithmetic sequence are the first 3 terms of a geometric sequence. If the first term is 9, find the ratio of the geometric sequence. The first term of the sequence is 9. The fourth term of the arithmetic sequence is found adding 9 and 3 differences. The 8th term is found adding 7 differences. Since these 3 are the first 3 terms of a geometric sequence, that means that if we divide the second by the first, the answer is going to be the same than if we divide the third by the second. All we have to do is solve this algebraic equation. You could stop the video here and give it a go. Right? I'm gonna use cross product. Expanding brackets and rearranging, we are left with the quadratic 9d squared minus 9d equals 0. Factorizing, I can see that d equals 0 is one solution, but this makes no sense. So we use the second, d equals 1. Replacing d with 1, we obtain the geometric sequence 9, 12, 16, etc. The ratio can be found by dividing 12 by 9 or 16 by 12. That is 4 over 3. This third one is a 5 marks question. Find the term independent of x in the binomial. Even just an attempt at the binomial expansion using a relevant row of Pascal's triangle will give you 1 mark. So it is worth to try, even if you don't get the final answer. The nth term of this expansion is given by 10cn, the coefficient, times 2x squared to the power of n times 1 over 2x cubed to the power of 10 minus n. Expanding these 2 powers and simplifying, we notice that we have those terms in blue. They are just constants, regardless of the value of n. The term that we need to worry about is the x to the power of 2n minus 30 plus 3n, which simplifies to x to the power of 5n minus 30. If we want to figure out the value of n that makes this constant, well, the power has to be 0, because x to the power of 0 is 1, but x raised to any other power will return some x's. 5n minus 30 is 0 when n equals 6. Substituting n equals 6 into our expression, returns 840. That is the independent term of our binomial, the one that contains no x on it. These are just 3 examples of higher maths questions. For more practice, watch the playlist. Until next Wednesday, happy learning!